Welcome everybody. Hello Frankfurt, hello world. Thank you for tuning in for this combining analytic methods to unlock sequential and temporal patterns of self-regulated learning. So I have in my team, I have some learning analytic superstars here, and that's Winisa Macha and Norayu Amaduzir. A couple of other guys, they're up and coming talents. With a bit of guidance, I think they might go far. That's Dragan Jazovic and Abelardo Pardo. So, moving on. Just looking at the research scope, the educational context is blended learning. It's a blended learning environment from which we've extracted the data. What we concentrated on was the online side of it. So obviously there was a face-to-face element. There is also self-report data attached to the overall experiment, but we are concentrating on the trace data, and conversations about trace data versus self-report are for a different time, a different paper, but it is something to discuss. So we've got all this data, so the question is how do we make sense of it? We've chosen to use a model of self-regulated learning because it has synergy with the sort of rise of digital platforms. So we found it really useful as a means of framing our analysis. The analysis itself, the sort of discovery methods, we're moving in the areas of temporal and sequential dynamics. We're shifting a focus away from traditional statistical methods, which have merit, and we just want to try and articulate our findings in a mode of, as I say, sequence, temporality, process. So what this paper essentially is, it's actually an exploration of methods. It's an exploratory paper. I can't claim it to be confirmatory. It's an exploration of methods, and we're looking at micro-level process analysis, which I'll discuss in a moment, for the pre-processing of that raw data. We briefly touch on sort of very simple frequency measures, but the focus is more on this sort of event-based algorithms that we're using, which is process mining algorithms and epistemic network analysis as well. Okay, so the research questions. What we're doing is we want to use that sort of a combination of those methods that that I've just described there through the lens of self-regulated learning, and we want to do essentially three things, and the research questions are there, but essentially we want to characterize, can we characterize student behaviors in the context of self-regulated learning? Can we compare different groups of students based on things like assessment score? Okay, can we articulate different strategies, different optimal or suboptimal behaviors from students from different sort of academic ability? And finally, can we consolidate these methods into a sort of a coherent mode of and a coherent narrative that allows us to articulate that temporal, sequential dynamic that we're trying to achieve here. We're trying to move away from just sort of ontologically flat statistical measures. So that's what we're trying to do here. So we're using in the event-based side of things, we're using three discovery methods: epistemic network analysis using RENA, sort of temporal process mining using BUPAR, and we're looking at stochastic mining, first order Markov models, using PMiner. So we're using three different modes there. Just to step back a bit and look at the origin of the data, it's from a sort of a learning management system attached to a blended learning course from an Australian university. We have 3 years of data. You can see there's a metrics, 239 students and nearly 300,000 learning events. So of course, each course lasted 3 weeks. There are three elements to the summative assessment. There are 2 offline summative assessments in week 6 and week 13, and there is also embedded into the online element. There's a weekly select sequence of summative tests, summative tasks, which contribute 10% to the final mark. So 10% doesn't seem like that much, but it actually turns out to be significant in the studies, as it provides a focus for the students, because they want that extra 10%. In terms of data curation, every time a student engaged with an element of the learning management system, they generated a record. So student ID, timestamp, and a learning action. Data that was added post-collection was a session ID, this was just a categorisation of just a sequence of activities, determined temporally. So if someone stopped a learning activity for a certain amount of time, then started again, that would be determined as a separate session. Okay, and that is important for this study as well. We're talking about event-based discovery. So for both process mining and ENA, there are the events that we captured fed into that in a number of ways. So we're talking about a case, which is it's a process instant, and it could represent a human actor, or a more sort of abstract concept like a learning cycle, or a sort of a temporal passage within a sort of bigger structure. In this study, we used both student ID and session ID as that case. The activities is a well-defined step in a broader process. We could have used just the raw learner actions. In fact, I did do that in a previous study, but in this one we used the micro process action, and I'll discuss that in a moment. And timestamps. The timestamp is critical to this kind of study and critical to the whole research scope. Okay, just to talk you through some of the learning actions that sort of, broadly speaking, we can categorize them in 4 ways. We've got sort of knowledge acquisition in terms of accessing videos or content. We've got formative work, formative multiple choice questions, so the student engages with these are all online activities, engages online and can solicit, if they want to, they can solicit answers to the multiple choice questions. We have summative assessments, as I say, these summative activities which contributed to the final assessment, which provided a significant focus for these students. And then finally we have sort of more metacognitive sort of strategic activities like accessing the dashboard, looking at the learning objectives, looking at the index page, looking at the project instructions, and so on and so forth. So that's the sort of raw learner activity. So we've got an example here of I say it was raw, there has been some curation here, but here's an example of the data as before we transformed it, and we could look at this, and I'm hoping you can see my little arrow there. So we've got somewhat orientation, looking at the learning outcomes, looking at the dashboard, looking at the index page, a little bit of content access, again then sort of looking at evaluating the dashboard again, and then jumping straight into the summative work, so that they haven't attempted any kind of sort of knowledge acquisition there. They've really just over the course of these sessions just abdicated responsibility for their own learning and jump straight into there. So you might interpret that as being suboptimal learning, but how can we assert that? So I can't really talk about self-regulated learning without reference to the sort of some of the godfathers here, sort of Winnie and Zimmerman here, and as I say, we built our sort of analysis on a cyclical model of self-regulated learning. It probably aligns a little bit more with Zimmerman's, but they both suggest that there's a cycle of sort of planning and forethought, followed by a phase of performance and engagement, and then a phase of reflection and evaluation. So they both, Winnie's is more sophisticated, I would say. But they both point to that sort of ongoing cycle of learning that happens, that has been proven to happen in students, and particularly in digital environments. So we're using that, and we've built on and Green and Azevedo and Sayadati's excellent work on micro-level processing, which seeks to embed analyses in real models of learning. And so I've used their identity, I've simplified it a little bit, but used the model that particularly Sayadati developed, which looks at three constructs of self-regulated learning: planning, engagement, and this evaluative stage at the end, evaluation and reflection. So what we do is I've broken it down a little bit. So planning is goal setting, plan making. Engagement is working on a task. Then we've got evaluation and reflection. And how we define those is by sequences. We take those learner activities, sequences of learner activities, and then we parse them, we interpret them, and then recategorize them as these microprocesses, which we can see here. So these microprocesses which we generate from the raw data are themselves relate to the micro-level process within our model, which are then sub-processes of our model of self-regulated learning. So we're attempting to sort of to embed our research in a model of learning. So how we did that, we wrote an R script, which basically parsed the raw data, and we built up a sort of a regular expressions pattern library, which then we fed in the raw data, and then that spat out at the end something called an eventized lock, and we call this event the eventization process. Okay, so just to flip back to what that did, you can see in the background we've got that example of our raw level data, sort of raw data. We put it through our engine, and then it gave us this sort of essentially this coarsened version of the data, which you can see I've got the sequences there. Depending on the sequences which we saw in that table back there, I don't have time to go into a huge amount of detail, but based on different sequences of activities, they're either working on knowledge building, making plans, goal setting. You see summative tasks there, and then so the different combinations there, and you can see the examples, combinations of MCR and index and access is goal set, for example. Working on a task formative is a combination of correctly and incorrectly answered multiple choice questions. So there's a variety of different sequences that our regex pattern processor worked through, and it gave us this. So this gives us as I say, a coarsened view of the data, but a cleaner view of the data with less noise, and something that we hope is embedded in a sort of a model of learning. All right, so some of the results. So I'm just going to sort of highlight some of the results, and they are sort of more, as I say, more exploratory and qualitative in nature, and there's a sort of a bit of iconography going on there. Excuse me, the sort of for being a little bit crude with this, but the better performing students I've given a green thumb, and this is the sort of lower performing students based on basically the upper and lower deciles based on assessment scores. It is a little bit crude. It's just for the purposes of this presentation. It's not in the paper. I've also my research questions. I've put them there at the side, so you can easily identify. So what we can look at is we're just looking at frequency measures, and we can see that sort of knowledge building, the sort of upper decile. Generally speaking, there's a sort of a slightly greater emphasis on knowledge building than the lower decile. So that's a sort of a comparative analysis there, and we can see that summative work, that one that gives you to that 10%. You can see that the lower decile focuses a little bit more on that. So they're small percentages, but it's a large data set, so they do have significance. So that's frequency measures. So we can get a certain amount of value from that. But I'm just looking at the time there, so I might have to speed up a little bit. We're looking at epistemic network ENA output here, and again we've got characterizations there and a comparison. as we can see here, that the thickness of the lines between the nodes shows us the co-temporal association. So these things tended to happen together. The position of the nodes in the quadrants, we can imbue this with qualitative interpretation. So we could say this is sort of working on a task, is in the it's sort of task working in the sort of top left quadrant. In sort of formative building, knowledge building, goal setting, we see is set out down at the bottom. Yeah, and then we've got summative work, which is sort of in the middle there. So we could use these positions to sort of actually question whether our model that we're using is valid or not. Okay, right, 10 minutes. I've got to move on. Right. So we're looking at temporal process mining, and again, this gives us this extra dimension that we didn't have with the with frequency and ENA. It allows us to look at the focus on certain tasks. So we'll see that, for example, we've got a making plans node there for our optimal learners that doesn't exist for our suboptimal learners. Because it fell below a sort of a metric benchmark, we can see that working on a task was, in terms of temporally, was something that was focused on specifically for both students. It was a task that they all focused on, and obviously because that gives you the 10%, you'd understand why. Okay, probabilistic process mining. So this is a first order Markov model. So the lines between these nodes are transition probabilities. So we could say from this particular example that at the beginning, the optimal learners, they're as likely to start knowledge building as anything else. Okay, that's the most likely session activity or phase, shall we say, from a standing start. And then from then they're likely to go to formative work from knowledge building and likely to go back. So you can see these sort of quite sort of reasonable and ordered patterns of learning there. This is a comparative, and these are quite useful. What we have here is suboptimal learners mapped onto optimal learners. So we can actually compare the transition probabilities between the nodes there. So we can see there that from formative work, an optimal learner is likely to go to working on a knowledge, more likely to go to knowledge building than any other task. However, the suboptimal learner, which is that's 0.37 at the side there, is less likely to go. So it affords us the ability to sort of comparatively, visually analyze the differences in learning sort of strategies and movement and sequence in a comparative way, in the context of transition probability. So it's all feeding into this sort of temporal and sequential mode. And likewise, if we look at this other area down at the bottom there, we can see that from from formative work, the suboptimal learners are more likely to seek out answers to the quiz questions than the optimal learners. So you can just read into that just a different way of attacking formative work. The optimal learners are more likely to try and build up the knowledge organically as opposed to just soliciting the correct answers. Okay, so the discussion. So really, although I've talked about some of the metrics in those discrete methods, what we want to do is consolidate, and the consolidation is a more sort of qualitative narrative. So we've looked at the discrete interpretations there. What we want to try and do is try and bring them together, and it's still a work in progress. So we could suggest that instead of talking about these in turn, we could say learners more actively engage in cycles of knowledge building, formative work and summative work than any other. Although knowledge building is most frequently engaged in, more time is actually allocated to summative work. And summative work is more likely the most likely point of engagement after phases of reflection and goal setting. Knowledge building engagement is the most likely destination as a breakout activity during cycles of formative work for the top decile, with the bottom decile favouring access to quiz answers. So it's what I'm trying to do there is try and articulate the different modes of analysis and the different I guess the different sort of visualization methods in a single narrative, to try and capture that articulation of sequence and temporality. There are limitations, as I'm sure many of you will be crying out to tell me, that the questions must be asked about the validity of the measures. It's an exploratory analysis. We've used a model of learning, but really we need to sort of tighten up the validity of what we're saying, our interpretations. What I'm making assertions about sequences of activities, but who's to say that that's what is actually happening? It has limited classroom impact as it stands. It's at the stage where it can't really be transferred immediately to another setting. We did a sort of qualitative consolidation, but we didn't consolidate the metrics, the transition probabilities, the temporal measures. We still haven't sort of cracked that yet. And generally speaking, the formalized method of consolidation has not been fully defined. However, the next step is this: we're going to do a systematic review of literature, which we're really going to sort of crystallize what's happening in this particular area of research, which from that we hope will provide us a framework, a framework of guidelines for a stronger set of empirical work, and also a final study based on that, which will be a proof of concept of this framework, and hopefully a move towards a formalization of a method. Okay, so thank you very much. So I'll finish that now, and I'm open to questions.